Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight we're going to take a look at dynamic geometry. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. And with us tonight is Judy Hicks and Tom Reardon. And I know geometry is pretty important to both of them. It's near and dear to their hearts. Judy is a T-Cubed instructor out of Colorado, and Tom is a T-Cubed instructor out of Columbus. So Judy, it's great to have you with us.
Thank you, Mike. Good to be here.
And same, Tom, great to have you with us as well.
Hi, Mike. Hi, everybody.
Tom, will you discuss our agenda for tonight?
Sure. So what we're doing tonight, welcome and introductions, which we just did. We're going to illustrate the menus on the TI-4CE Cabri Junior app, show cool dynamic geometry activities using Cabri Junior, then illustrate menus on the TI-Nspire CX Geometry app and show the same cool dynamic geometry activities. Learn where to obtain these pre-created activities for both platforms. And then Mike's going to do the webinar drawing at the end.
Thanks so much. And Judy, will you discuss our expected outcomes?
Sure. So by the end of the hour, we should be able to find geometry activities, use those activities, in a confident way, and then maybe even create some of your own, which we'll do a little bit tonight too. And then Tom will be sharing a bitly later as to where the files are if they're not on the website. So
Thanks so much, Judy. We're expecting a large crowd tonight, so your audio is muted. Feel free at any time to send any questions to Judy or Tom. I know they'll do their best to get those questions answered live. We will be using that Q&A window on the right side of your screen tonight for those questions, and the chat window also on the right side of your screen to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. So without further ado, Judy, it's all yours.
okay. Thank you. I'm going to stop my video first. All right. Give me just a second here. First thing geometry. And I'm
Hey, Judy, it sounds like you're breaking up, and I don't see your content just yet. Tom, are you seeing the same thing? Yeah. I'm gonna try something real quick. So, Judy, I just took control back. You want to try taking control again and then sharing your screen, Judy? Well, hey, Tom, any chance you want to swap with Judy and maybe we can swap with you?
We can go ahead and do that. And in the meantime, maybe you can give her a text or something to see what's going on. Do you have her number? Gotcha. Okay. Well, let me go ahead and share, and hopefully this is going to work out okay. Great. There we go. So, Mike, you can see me okay? In here. Okay. So how to incorporate cool geometry activities in your middle school and high school classrooms, geometry classrooms. Judy stepped out for a second, but this is my contact information. This is the bit.ly that has all the information. Michael put it into the chat. I will show it several other times. I'll refer to it, but everything is there. And so if you say, boy, he's going really quickly, he's illustrating things, but I have PDFs of step-by-steps on how to accomplish these things. So sit back and relax and say, oh, I like that. I want to know how to do it. Or, that's not really for me, whatever. All right, so I'm going to start with the TI-84CE Cabri Junior app. So those of you who are 84 users want to pay more attention. In fact, you know what? If we could put in the chat, if you could put in this, if you're an 84 user, more likely put in 84. If you're Inspire, put a capital N. And if you're both, put the word both. So if you could put that in the chat right now, 84 for primarily 84 CE user, N for Inspire, and both for both. And that way I can kind of get an idea of where people are. I am going to be showing both things, but it's a good idea to know where we are, what my audience is. So thank you for answering. If you haven't answered yet, please do so. All right, so we're going to start off with the TI-84CE Cabri Junior app, okay? And I'm going to show you a lot of pre-created activities that you have access to. And not only that, you have step-by-step on how to do it. For example, here's the first page showing you how to open a pre-created Cabri Junior file, okay? So it goes 1, 2, 3, 4, 5, 6, and so on. So you have access to this PDF, okay? So let's go ahead and look at one. We're going to start simple. So let me bring up the 84 and I'm going to go to apps. And the second one on mine is Cabri Junior. And I'll press enter. And there it is. Okay, it says press a key. So I do know the menu keys are under these hotkeys along the top, F1 through F5. So if I press Y equals, I can go ahead and open a file. So I'm going to go ahead and I'm under F1. So I'm going down to open and I'm going to press enter. And I want to find one that's called linear pair. So these are alphabetical. And there we go, linear pair. Someone asked about the bit.ly. You'll have plenty of chance to get it. Michael, type it in, I'm sure. Okay. So notice it says linear pair right here. So I'm going to press enter for OK. And do I want to save changes to what I had before? The answer is no. Okay, so I'll leave that alone. So here I have two intersecting lines, and I have already constructed them. I've already measured the two angles that are adjacent to each other here. And what I'm hoping students is can just mentally add those up, those angles up. So now for those two, those add up to 180, but I'd like to do several, and this is where the dynamic geometry comes in. So I'm going to go ahead and move my cursor by using the up, down, left, right keys. Okay, and it shows that right here in the step-by-step. And when I get to something that I can do something with, it gets kind of dotted, but it also says alpha. Alpha is the grab hand. Okay, so now that I've accessed this, I'm going to go press alpha, and that arrow is going to turn into a grab hand. And now I can use the up, down, left, right keys to move this. And you can see as I move it, the angles are changing dynamically, and the angles keep adding up to 180. And so I can play a lot with this and have students investigate some of the mathematics that we just come in and say, this is how it is. Okay. So that's the linear pair. Let me pull that one off there into the, and I love to use this when I'm teaching, is how I can pull the screenshot off into either a Word document or PowerPoint, or in this case, I'm using Smart Notebook software because that's what I like to use there. So I'll go on to the next page, and so they misspell on purpose. I can only use 8 letters. So so that's why I have to misspell it. I've got 8 characters that I can use. So I'm going to go now back to Y equals, and I'm going to open up.
Tom, can I stop you? First of all, thanks for jumping in. I have no idea what happened. And sadly, I said all this great stuff that I'm sure that you guys couldn't hear. And so it's not going to make sense, but you're doing everything that I was gonna do anyway, so I will just, type in here. There was a question from Olga asking if you could show some of the angles on the screen. I don't
I
know
will
if you
get
were,
to that in another one.
that's what I
Okay.
thought.
Yeah,
Yeah.
I'll get to it in another one. So, yeah, so right now I'm just kind of easing into it. So Olga, hold on just for a couple minutes there, and we'll show that. Okay. Judy, you don't want to show your stuff though?
No,
You
just
wanna wait till the
keep,
end?
no, because
Okay.
mine was gonna be all intro and you're
Okay.
covering the stuff anyway, so no
Okay.
worries.
All right. Okay. All right.
Sorry.
No, it's all right. So again, these are in alphabetical order. So I'm going to go up to go to the end. And there's vertical angles, okay, with the misspelling, as some of you pointed out. And again, I've got these already pre-created. You could create these, but to me, for a lot of this, it's time not well spent. Okay, there's some certain times it is, but this isn't one of them. So again, what I would ask my students to do is move their cursor until you get to a line that can be moved. And so again, you'll notice this line can be moved. So I'll press the alpha key to grab it. And now you can see that as I'm moving this, the vertical angles always have the same measure. So that's a conjecture my students can make on using several different examples. Okay. So again, I kind of pull that off and pull that in there. Then I had one that does both at the same time. And some of you might just want to say, well, I would just like to do both at the same time. So again, I'll go to Y equals and go to open. And this one is vertical linear pair. So this one here, notice I'm able to see the linear pairs, the supplementary angles here, supplementaries here, and then the pair of vertical angles. And then again, you can go ahead and grab that line and move it up or down, left or right, whatever, to be able to see that vertical angles are always congruent. The adjacent angles that form a linear pair are supplementary all the time, always add up to 180. I should point out to undo the alpha, press the clear key. And notice if I go over to the other line, some lines are not movable by the way they're constructed. So notice here, if I go to this line, as hard as I try, I'm not going to be able to grab it. So be aware of that. Be aware of that. Again, I'll pull that one off. All right. Corresponding angles, two parallel lines cut by transversal. Okay, so this one I called PAR and then core, so parallel corresponding. Again, all of these are available to you, and every single one of them has the explanation to them step by step on how to use them, because I know you're not going to remember this by just watching it one time. So I'm going to open this one up, and here I have two parallel lines cut by transversal. You'll notice that my parallel lines are not horizontal. I didn't want them to be because we see them like that all the time, okay? And I did measure the angles here, the corresponding. So again, I'm going to go ahead and try. Let me see if this line will work. Will this line work? So this line will work. So I can go ahead and use the alpha key to grab that line, and then I'll pull it down. Notice it's pulling it down. Maybe I'll go to the right. That might be even better. And you can see that the corresponding angles are always equal, again, as long as those lines are parallel, and they were constructed parallel with that transversal. I also could do the alternate interior angles. I think I'll skip that, okay, but it is in there, okay. I do want to look at this one, interior angles on the same side of the transversal, because that's an interesting one. So I'll go and open this one. This is the one where I will show the calculation. So this is parallel interior same side. That's with my 8-letter abbreviation. And you can see that one angle is 125, one's 55. And I can mentally see that those add up to 180. But again, I'll go ahead and try to grab this line. And you'll notice I can't. Maybe I could go up and grab the transversal. By the way, stay away from the red points because I don't want to grab the points. Those will move along the line. Okay, so there's my alpha, grab, pull, and you can see that those angles always add up to 180. Okay, so I'll press clear to ungrab the line. And let's go ahead and show that they add up to 180. And even when I change them, they still add up to 180. So to do this, I'm going to go to the graph F5 menu, because calculate is in that F5 menu. And by the way, I'm going to give you a sheet with all the menus on it and some key ideas. I'll show that shortly, because I want you to be able to use these things like tomorrow. Okay, that's the whole deal. And I would love if you used them, if you sent me an email and said, I used one and it went great, or it stunk, but use it. So I'm going to go ahead and calculate. And so when you calculate, what you do is you press the one measurement or number on the screen, press a calculation, and then another number. So I'm going to go ahead and move my cursor until it points to 126. And you'll know when I get there because it has the arrow goes sideways and also a little underscore. So I'm going to go ahead and click enter. And then I'm going to press the plus sign. And you'll notice the plus sign got bigger right here. Maybe you didn't see that, or a little more pronounced. And then I'm going to say I want to add it to this other number. Enter. And as soon as I did it, notice a hand came up with the sum of 180. So I can put it on the screen where I'd like to see it. And I'll press enter to leave it there. And then I'll press clear to turn off the calculate menu. And so I'm going to go back. And this time, as I change the angles, the new angles are now going to be added. And the answer will be displayed here. Alpha grab, pull, and up and down. And notice that the angles are changing. The interior angles on the same side of the transversal are changing, but they always add up to 180. So with that, I'll stop and see if there are any questions or comments. And Olga, I hope that was what you wanted to see. Great. Thank you, Olga. All right. Any other questions? Put them in the chat. Judy will get them to me. Mike will get them to me. I might see them, but please, ask questions here. Oh, it says, and so I'm using TI-Smart View. Yes. All right. So this is what I'm supplying for you. These are the Cabri Junior menu items. So if you would press on Y equals, which is F1, this is what would drop down. F2, points, lines, and figures. F3 is the construction menu, okay? F4 is the transformational geometry menu, and F5 is whatever didn't fit, okay? Those things. So you're going to get that, and then on the bottom of that page, I have some key ideas to remember. How do you grab a point? Make sure you think about pressing delete or clear. Clear is used a lot. Delete doesn't do things you want to do. To type in text, it tells you how to do that. There is an undo command in F1, which I absolutely love. It's the only time on the 84 that you can undo. So for example, right here, if you go to Y equals, you'll notice that undo is right here. So if I press enter on undo, notice it changed where I was. So it undoes the last command or last function.
Tom, there's another question.
Okay.
In order to measure angles, the question is, do you have to go point by point, or can you do line and line? So can you try line and line just to show?
So yeah, let's go ahead and measure an angle on this figure right here. So measurement, I think, is under F5. So I'll go up to measure, and notice measure has a right arrow that says there's more stuff. And so angle, I'm going to go down to angle and press enter. And you'll notice in the upper left corner, it's showing me that I'm going to be measuring an angle. So what I'm going to do is I'm going to go to, say, this line right here. And I'm going to press enter, saying start with a point on this line, enter. And then move to the vertex. And notice it's got a little spider web attached to it. And notice when I get to that, exactly to that point, it's showing me you're not close to the point, you're right there. Enter. And then the third point will be along this line somewhere. And again, you'll notice it's kind of dashed, and I'm going to press enter. And as soon as I do that third point, it's showing me the measure of the angle, which I can pull off. And not surprisingly, it's 54 degrees. So I'll press enter to drop it there and then press clear to turn off that command. All right, so hopefully was all right. I did have a point on here. I could have started with that point that was on the line already, but you can just make sure you're pointing to the line because it's agitated, click. But the key thing is making sure you get to that vertex and not close to it, but exactly to it. So again, this is all available to you. I'll show that at the end. So now I'd like to switch over to TI-Nspire CX and using their geometry app. Again, so here's the bit.ly for those of you who came in late. Oh, wait, I changed it. I changed the bit.ly. Sorry. Pay no attention to that person behind well, forget that one. Okay, I changed it. So these are some activities that either I created or you can get on TI-Nspire, Math Inspired. Okay. And so this is the step-by-step here on how to do it. So I made a little table of contents. So we're going to start off with one of my, well, a lot of them are my favorites, but tangents to a circle. Okay, so this is like the first 3 slides off of that PDF that shows you step by step. So I'm going to go ahead and bring up TI-Nspire. So I see somebody said your TI-84 Cabri is empty. That's because you don't have any pre-created documents. I am going to supply them for you, and you can put them on your calculator or in your TI Smart View software and do exactly what I just did. We'll talk about that in a little bit. So here I am on TI-Nspire, okay, tangents to a circle. And maybe I'll make this a lot bigger here. Bigger. So this is the first page, page 1.1. And it's showing me two lines drawn from an exterior point tangent to the circle. So I'll go to page 1.2, and the very first thing is this, and you may not know what to do, and that's why my directions will be so helpful, hopefully, to you. But you'll be asked to grab point B and pull point B around, and notice that this tangent line and radius are perpendicular all the time. That angle is always 90 degrees. So a tangent line drawn perpendicular to a radius is tangent to the circle. Okay, so you're able to interact there. And if you want to make the circle smaller, you can. If you want to grab point T, you can't. If you want to grab point O, you can. Okay, so there's certain things you can grab and certain things you can't. All right, so that's kind of a cool thing for students to discover that. Next page is here we have that 2 lines drawn from an exterior point. I would like my students to think, hey, are segments AB and CB, are they always going to be equal? So what I'd like them to do is to go ahead and grab point B and pull it around. And looks like, yeah, those 2 segments are always equal. How about if I get really close? Now, if I get on the circle, then we get a problem. But if we go inside the circle, it doesn't work because they're not tangent. They're not externally tangent anymore. Okay. So looks like, yes. I could also say, is it only this size circle? And the answer is no. The circle could be any size. And I could move the circle. So this is really dynamic geometry at its best. Students can play with the math and then discover the theorems and then try to discuss why they're true. By the way, if you wanted to see the radii, you can hide or show them. If you want to show segment OB and then put in the radius, you can see now we've got 2 triangles that we might be able to get congruent. But basically, that's what the next one is for, okay? So I love this. It says use the arrows to proceed to the next step. This is a slider here. You could either click on the slider with your cursor, or since there's only one slider, you can use the up and down arrows to increase or decrease the slider, so you don't have to be pointing to it all the time. So I'd like to prove that these 2 segments are congruent, and the way I would do that is to prove triangles congruent. So I'm hoping students would say, well, I need to draw in the radii, so click and see. Oh, yeah, radii. And what do we know about the radii? And I'm hoping they're going to say that they're congruent. So I'll click the up arrow again. Yeah, they're congruent. What else do we just found out about the radii a couple slides ago? Yep, that they're perpendicular to the tangent line at the point of tangency. And I need to get triangles congruent, so I need to draw in OB, and that's the next step to kind of give us a hint to do that. And so now these two triangles are congruent by right triangle, share hypotenuse, leg, right triangle HL. Okay. And so they're congruent. Again, I'll press the up arrow. And so I'm showing this triangle right here, triangle OAB, and I'm going to show it's congruent to triangle OCB. And I'm going to go back to my geometry teacher, Mr. Erickson, who I wouldn't be here today if it wasn't for him. He would tell us that if triangles were congruent, you could put one on top of the other and completely coincide. And this is back in 1968. And geometry was really more faith-based. And now it's a little bit more technology-based. So it says drag point D. So I'm going to go ahead and grab point D and watch the magic happen. Oh, love it. Love it. Completely coincide, no doubt. And again, I can even grab point. Can I grab point B? I guess I can't grab point B. I can grab O, and I can grab this circle and all kinds of other things and show no matter what, those two triangles completely coincide and are congruent. So questions or comments?
This is always a favorite activity.
Yeah, yeah. I tried to pick wow ones for sure.
Yeah.
All right. The next one is area formulas. And I love this one because it helped me have my students decide why the formulas are the way they are. Okay. And so this one, I'll go on to page 1.2, and it says use the up arrow to show dimension labels. Again, I could either click here. I prefer to click on the click pad, and it's showing me this rectangle has a base and a height. And I like that because it's not length and width. And I'm going to be talking about triangles and parallelograms and all this other good stuff here. Okay. I did miss that page. So I should say we're going to be area formulas for parallelograms, rectangles, triangles, and trapezoids. Okay. And so we go to page 1.3, area of a parallelogram. And we're going to have a parallelogram and rectangle that have the same base and same height. So go to the next page. The directions are here, but if you don't want to use them, you don't have to. I'm just going to point it out. So I'm going to grab point H, and notice when I grab point H, when I make the rectangle bigger, the parallelogram gets bigger with the same height. If I grab this blue point here, the base gets longer or smaller. Okay. So the parallelogram and the rectangle have exactly the same base, the same height. And I would ask my students, do they have the same area? And most of them, untrained, would say, no, this one's kind of smashed. Okay. But now what I'm going to do is grab point P and pull it along here and pull it as far as I can. And wow, that parallelogram, I just took that right triangle and pasted it over here. And I can see that they have exactly the same area. They cover the same amount of surface. And some of you might say, well, I've done that with parallelograms with construction paper, cut it off and taped it over. And that's a great way to do this. But 21st century kids, I think they're going to be replaying this video. Plus, they're doing it. If they have it in their hands, they're doing it. Okay. So they would tell me the area of a parallelogram is base times height, not length times width. That doesn't make sense. Area of a triangle, again, same base, same height. I can change it. As I change the base, they change. As I change the height, they change. Okay. And this one, I've asked students, do they have the same area? And I've got some kids that will say yes. And I've got kids saying, you got to be kidding me. These don't have the same area. Okay. But what I want to do here is I'm going to grab point Q. I'm not going to drag it. I'm going to make a frown or an upside down parabola. And when I do that, I'm getting two triangles with the same area, same area. And both of these triangles make up the same area as this parallelogram. So the parallelogram is base times height. The triangle is half times base times height. And I'm showing them why. I'm not just saying, here's a formula to memorize. It works because you can see it. All right, last one is trapezoid. Okay. And here we have a trapezoid and a parallelogram that have the same height. They do not have the same base, okay, halfway through. But this one, watch this one. I'm going to grab point R and do that up and over again. And notice these two trapezoids make up the same area as this parallelogram. They have the same base 1 plus base 2, same height. The area of this is the quantity base 1 plus base 2 times height. The area of the trapezoid would be half of the height times the sum of the bases. I mean, that's the way it works, okay? And so instead of me saying, here's the formula, memorize it, and they'll say, this is too hard. This is why. It's not just because we make these up. So questions or comments about the area formulas one? Okay, there are, pop in. All right, next one is area measures and right triangles. Okay, I created this one with some help from Steve West, who I'll get to in a little bit. So here, some of you have seen this before, where you'll have a right triangle, and on each hypotenuse is a square. And we take the area of the square of one plus the area of the square of the legs equals the area of the square on the hypotenuse. Well, it turns out no matter what figure you use, this will work. And I saw this years ago on an NCTM video, long time ago. So you can see that the area of the blue equilateral triangle plus the area of the brown equilateral triangle equals the area of the green equilateral triangle. Not just for this one, by the way, this is a right triangle, ACB. But watch what happens when I grab point B. The areas change because I'm changing the lengths of the sides. If I grab point A, and no matter what, the area of triangle APB is always the areas of these two. This is, to me, really amazing. You can even go ahead and use semicircles. So I created semicircles on here. And the area of blue plus area of green is equal to area of red. And again, kids can try many examples. Now notice here, C doesn't change the triangle, it just moves it. So I can only change the areas of the semicircles and the by pulling A and B, but that's probably enough. The next one's really, I just put these ducks on here. I really can't find the areas of ducks very well, but I thought it was kind of cool. The area of the green plus the area of the pink should be equal to the area of the blue, okay? And then this one, Steve West, T-Cube instructor from New York, came up with this, and so I thank him many times for this. So here we have, somebody say, well, it's the same old thing. The area of these squares, add up. Pink plus red equals blue. But you can go ahead and make this any type of figure you want. In this case, these are pentagons, really weird looking pentagons. And they could even be concave. And so then pull it out and so on. So I thought this was kind of a cool thing to illustrate that. So questions or comments for that one? Again, you have access to all of these and the step-by-steps on how to use them.
Tom,
Yes.
Joshua asked, should this be used mainly for high school, or can middle school or even fifth graders use these tools?
I think it's kind of cool. I mean, just to get their attention. I'm not sure about fifth graders, but I would think middle school would be fine with it. 7th or 8th grade should be okay with it.
Well,
But you know your students better than I do.
And isn't that where they now start Pythagorean theorem and stuff in middle school?
Yeah, my granddaughter, I was working with her on Pythagorean theorem in the 5th grade. I'm not sure I want to bring these in for 5th grade. Now that I think about it, I think the squares would be enough. Okay. But it might be a cool thing to show. I think this one's really cool, the semicircle one, because you can kind of see it. But yeah, that's kind of up to you. I'm not sure about that. But thanks for your question. All right, the next one is one I created because my students had so much trouble with base and height and altitudes, okay? So I'm gonna go through this kind of quickly, but see what you think. So for example, and this is really more like a PowerPoint on a TI-Nspire. So I want them to realize that segment BD is the height for this base, okay? But I could also, and then how do you find it is 1/2 the base times the height, okay? But I could also have segment AE be a height, even though it's not going towards the bottom. You know, this is my base over here, okay? And if I measure those and do the area formula, I still get the same answers I got before. And then, of course, I got a third altitude with the third base, same area, even though these are different measurements, okay? I want them to realize that. So they get that okay, usually. The hard part comes, oh, here's where they are heights into the different bases. And again, they're concurrent here. But segment AD is the height for this segment BC. That's okay. They're usually okay with that. But here's where it gets difficult, as all of you know. It's drawn perpendicular to the line containing the opposite side, and it's hard for students to see that, okay? And again, here's another one where it's an obtuse angle. So I'd extend this to a line and draw perpendicular to that. Our right triangles, this leg here, AB, is the height. Well, this is the base, but I can just as easily switch them, base and height. And then the third one realized that I'd get the same area if I use the hypotenuse as the base, and then this inside height for the altitude. And then the last thing, after showing those are, again, and I like this because it took so long to draw them on the board. And here I can have students go at their own pace and decide how much time they need, and they can always go back to these, okay, which is kind of cool. And then the last thing, I forget where I got this from, but here we have a blue triangle ABC. We have the lengths of the sides, we have the base, we have the height, and we have the area, okay? And these two lines are parallel, okay? So I'm going to grab point B, and as I pull point B, notice that the AB and BC are changing. The height is not changing, the base is not changing, and neither is the area. And this is just such a cool way to show that, as long as these lines are parallel to each other. So stop there. Questions, comments? All right, circles, angles, arcs. This one here, grab point A and move it around, and you can see that. And then all of a sudden, okay, you say, well, what happened here? Well, it's a good idea to show this minor arc and major arc. So the minor arc's in gold and the major arc is in blue. And so we could talk about how those two add up to 360 all the time. And then all of a sudden, notice the minor arc is always less than 180, major arc is greater than 180, okay? Intercepted arc, here we have a inscribed angle, and it's one, you can might see that it's 1/2. And notice no matter where I put this point, it's 99 degrees. But if I change the intercepted arc, the angle is different. And notice it's always 1/2 the measure of the intercepted arc. I might have a rounding error here, so you might have to be careful about that. And then here, I kind of like this. If the angle is intersected outside and they intercept the same arc, this angle's smaller. If I go on the circle, it's equal. And if I go inside, it's greater. And it kind of shows you the ratio there for that. So it's kind of a cool demonstration.
And I'm sure, as Tom probably said, that I missed, with all of these activities, there are student activities that go along with them that question the kids. So yeah, they're dragging stuff around and moving things, but every so often it will ask them, you know, what do you see? What do you notice? What do you wonder? Do you notice that something is half or whatever? So I'm sorry if you already said
No,
that.
no. I didn't say that, but on the ones that I'm showing, I have this. So you'll notice advance to this page. What do you notice? What do you wonder? Grab point C, pull it and observe. Grab point B, pull and observe. Right, make a conjecture. What do you notice? What do you wonder? Those are all throughout the ones either I created and the ones that TI has on their website. They have student worksheets with teacher notes and solutions. So yes, this is not just play. It's guided play. It's make sure you get to the right spot and discover things. So yeah, thanks for pointing that out, Judy.
Mhm.
All right. I think so tangents, we did that. Let me see how many left I got. So circles, triangle sum. I'll go last one. I'm gonna do this because I want to go back to the 84. So this is triangle mid segments. It's one of my favorite activities. And again, this will be on Nspire, and then I want to go back to the 84. So triangle mid segments. There we go. So I'll go to page 1.2 and notice we have triangle ABC with DE and FR midpoints. They were constructed that way. So I have DE measured and I have BC measured, okay? And I want to know what's their ratio. And just by looking at it, I can do mental math pretty good, but my students might not be able to. So again, I grab point A and that doesn't change any, but if I grab point C, notice that the side lengths change. And so what I'd like to do is actually calculate the ratio. And so on the next page, I do that. I have them calculate the ratio, but that's just for this one pair. Okay. So if I grab point C and as they change, notice it's again showing me the quotient of those new dynamically changing lengths. Now, somebody said, well, it's not exactly 0.5. Again, we're not showing all the significant digits, but when it comes down to it, it is 0.5. So this segment is half of this segment. I'd also like to talk about perimeter of DEF as compared to ABC. And so you can see here that it looks like it's about half, okay, about half. And when you get to here, you can see that it is 1/2 and it does the calculations for you, okay? And the reason for that is each of these sides, DE is half of BC, EF is half of AB, DF is half of AC. So you can have the kids talk through why that's the case. Another thing that we'd like them to pick up on in this is that about the areas, okay? What about the area compared to this? And you can see it's not 1/2, and hopefully you can see what it is, okay? Again, I can grab, and I don't know if I can get this to be a nice whole number or not. Oh, almost, and see a little bit of a rounding thing there, okay? But on the next page, I do have it, and notice it's 1/4. And it makes sense because these 4 triangles turns out to be congruent. So this is going to be 1 out of the 1, 2, 3, 4 for the big triangle. All right, so with that, I want to go back to the 84 and talk about triangle mid segments on the 84. And this is one where on the Nspire, I can have different pages, but on Cabri Junior, I can only have one page. So I have, I created several different pages. And I called it try mid A, try mid B, try mid C, and so on. And I have on there what it does. So let me go ahead and open up try mid A. So go to open and go down to try mid A. There's try mid. I need to go back up. Yeah. So here's try mid A. So I'll open up that one. Do I want to save changes? My answer is always no. So here I created this that shows you midpoints, okay? And so what I'm going to do is I'm going to go ahead and grab point A and show that those points are going to remain midpoints no matter what. So again, that point is agitated. It's telling me I can grab it by clicking on alpha. I'll grab by clicking on alpha. And now I'll move this and notice that, yeah, the side lengths are changing, but those points are still always midpoints. And I could grab C or grab B and so on. Point, I cannot grab D, E, or F because those are locked in as being midpoints, so I cannot move those. Okay, just so you know. Again, I'll press clear to undo that. Not undo that, but to turn that off. All right, so now I'd like to go ahead and look at part B. And so I'm going to go back and open up try mid B. And this one measures the length DE and BC. And I already calculated their quotient to get 0.5. I did that just to save time. In the classroom, I would not have that. I would have them actually see how to do that. But now I'm going to go ahead down to point C. And what I'm going to do is for this one triangle, yeah, DE to BC is a half, but I want to see if it works for many, many. Okay. So again, I'm down to here, alpha grab, move it around, and notice that the lengths are changing, but their ratio is always 0.5. Okay. So I've got that kind of taken care of there. So these are all of them right here. I do want to look at G then E. So let me try G then E. So again, I'll go ahead and open, and I'll go down to G, and I didn't put them in alphabetical order, but that's all right. So this one here, what I'd like to do is talk about the perimeter to DEF to, or ABC to DEF like we did before. Remember, it was 1 to 4, in this case, 4 to 1. And again, I would ask them to pull them around and play with it. And then when I do that, E is going to be the one that has the answers in it. So after that, I'll go ahead to E, open that one, and you can see that the ratio, I'm not 1 to 4, 2 to 1. Sorry, not 1 to, sorry, my goof. So now I'm going to go to point C, and again, alpha grab, pull it around, and oh, sorry. Oh, this is a good thing to find out. I grabbed letter C, not point C. So I'm going to grab a point C, and that's going to happen to all of us. There we go. And I know it is because now it's blinking. Okay. And now I'll go ahead and press alpha. And now I'll move and change the sizes of the triangles. But the ratio of the large triangle, the small one, is 2. The last one, I'm going to skip the last one. It does the areas, but it's very, very similar. So on the Cabri, even though you can't have like pages, what you can do is create a document, save it with a different name, add to it, save it with a different name, and then just keeping opening and closing it. But these pre-created documents are all available to you. I highly encourage you to use them. This is well worth the time to have students investigate the geometry. Questions out there, Judy? Anything pop up?
No, not too much.
Okay. So I do want to finish up with transformational geometry. And we're going to look at that on the CX only because I'm kind of running out of time. So let's go ahead and look at reflections. We'll look at the easiest one probably first. So these are on both the middle school geometry website on Nspire and the geometry website, which I'm going to show you. Okay.
Okay,
So
that's what I was just going to ask, because I was going to do that too, because people are asking that.
Okay. All right. Good. So this is the first page of the document. Go to page 1.2, and it's kind of showing you like previews of coming attractions, what we mean by reflection about different lines. Okay. And the third page is actually a picture I took many years ago. This is the Taft School in Connecticut. And the reason it's here, well, hopefully it's obvious. You can't get much of a better reflection than this. Okay. So with that, we'll go ahead and get to this page right here. And what I'd like to do is reflect this over this line. Okay, the directions are all in there. I'm just going to go and show you. But again, there are about 7 or 8 different activities you can do on reflections, 7 or 8 on dilations, and so on, each one. So I'm going to go ahead and reflect about there. And you'll notice as I reflected it, you can see what happened. But also I asked it to put in these connected segments because I want to see that B prime is the image for the pre-image B and so on, and that these are perpendicular and that these are halfway between. Okay. So, and if I want to change the reflection line, I can go from a horizontal to a vertical, and then I can grab point B and point A and point C and do all kinds of manipulation and experimentation. Okay. And then I can even go with a slanted line. And I can't call it y equals x because I don't have a grid here. And somebody may say, well, yeah, where's the grid? The experts say you do not start with a grid when you do any transformational geometry. You let them discover it without any numbers or any grid and so on. But we definitely can get to the grid. So let me go ahead and get to the grid, and let's do one with grid and coordinates. So here I have this triangle right here, and I want to reflect it, let's say about this line. So I'll go ahead and reflect it. And now you can see where it is, but look at the pattern on the coordinates that you already know, but you would like your students to discover. And in the past, I've heard teachers say, oh, when you reflect it, the X stays the same and the Y is its opposite. And you got to memorize all this. Whereas I would prefer that the kids just learn that on their own from grabbing and moving things around and seeing that happens. And then I can go ahead and change it to X equals 0 and see when I reflect about the Y axis, what's happening there. And here the Y coordinates remain the same and the X coordinates are opposites of each other. Okay. And even I can do, weird things like this. Okay. And then I can go with the line Y equals X. And you can see that if XY is on one, YX is on the other. Okay. And they can investigate that. So there are a lot of things you can do here. There are several templates here to do different things. You can talk about slopes, perimeters, areas, angles, sides, and so on. But in this short time, I've got to go on to rotations. Again, this page here kind of shows some rotation things here. All right, so for this one right here, I'm going to rotate triangle ABC about point P through an angle of 45 degrees. So I'm going to go click on the rotation icon, and it just went 45 degrees, keeping track right here. I'll click again, and now I've gone a total of 90. But notice it's showing me the ghost of my last one. I'll go another 45 and another 45 and so on. And if you wanted to, you could even show all of the images as you're going along. That is an option to show, which is kind of cool. I'll turn that off. But I can also say, my students will say, how do you do this? How do you rotate by hand? So we included some things on here and say, well, watch here as I'm rotating this, okay? You see they're moving along arcs, and you can see that those arcs are along a circle. The vertices are along concentric circles. And then finally, you can see the arcs right on the circles. So this is a really good way for students to discover how do you actually rotate not using technology. Okay, you need a compass, a protractor, and some patience here. Okay, and again, I could go ahead and bring up a grid if you want to talk about a grid, and I could change the angle of rotation to be, let's say, negative degrees instead of positive degrees. And so let's rotate negative 90 degrees and see what that does to the coordinates. Another negative 190, another negative 90, and so on. And you can see what's happening there, okay? And there's a lot of things on here. You can talk about perimeters and areas, angles, distance to the vertices, slopes, all kinds of cool things, okay? But again, I'm running out of time, so I'll go to translations. And on translations, you can translate two different ways. You can say, well, I'd like to go up 2 and to the left 5, and then go ahead and translate it. And you can see that these look like they're still congruent. And then I can grab point C and see that the triangles are congruent no matter what, okay? I can also change the translation to be a vector, and your physics teachers would love if you did the vector. So I'd like to translate this triangle right here using this vector. So I'll go ahead and translate it. And then to show that, how about if I do this? Grab the vector and show them. Every single point is moved along that direction, along that distance, every single point, okay? And then when I change the direction, watch what happens, or change the distance, okay? Really cool things that you can do with translations. And again, these are all the things you can do with that. Finally, dilations, really quickly with dilations. Here, I'm going to dilate this with a scale factor of 3. And notice the perimeter, okay, here. I can also look at the areas of these. And again, I can change these. Oh, look at that. Look at the ratio of the areas there. Wow. And if you're not good at of seeing what it is, look at the ratio of the perimeters here. No matter what the perimeters are, is going to be 3. And the ratios of the areas is 3 squared or 9. And it even kind of tells you that here. So you can do kind of a lot of discovery things with that. So with that, let me go ahead and show you where all this stuff is. Thank you for paying attention, and I'm hoping you found some cool things here. So at Math-Inspired, you can get a thing on like units on geometry. You can also get middle school. There are a few of the middle grade geometry things. On TI-Nspire Activity Central also has units on geometry and a middle school geometry section. And so this is the bit.ly, this is the website that has this. Let me show it to you live. And there we go. So this is the website. It has Judy's and my email address and my website, my regular website. But here are all the TI-Nspire CX files in a folder. So you'd have to download it and unzip them, but they're all there. You've got them. The transformations with lists in a zip folder, which what Judy was going to talk about, that's there. Unfortunately, her computer went hooey on her. Here are the step-by-steps that I promised you, the PDFs. This is the table of contents, and you'll notice it shows you step-by-step, and it has questions for your students. What do you notice? What do you wonder? How would you create an argument? And so on. They're all there. A couple other things I didn't get to. The transformation geometry website's there. Math-Inspired is there. And then same thing for the 84. All the 84 files in a zip. Transformation with lists in a zip folder. The Cabri geometry activities, step-by-step PDF for that. Okay, so you've got all of those. So plenty of stuff. And if you have trouble putting these on your calculator, on your TI SmartView software or in your software, remember you can also do this Inspire things on the iPad app. Remember that. TI tech support, 1-800-TI-CARES. They're there. They're waiting for you to call them. They will help you do anything at all that's techie, anything. So you say, I don't know how to put this on. I don't know how to undo this, whatever. There it is. So Mike, I'm giving you 2 minutes. So hopefully that's enough. Thank you.
Thanks, Tom. I'll take it. That's perfect. All right, as promised, we are giving away to one lucky winner a TI graphing calculator of their choice. And this week's lucky winner is Nigel Ong Mint. So Nigel, congratulations. Start thinking about which TI graphing calculator you would like to receive, and I'll be in touch soon over email. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents that I used and Tom used. So if you want my documents for any reason, click that link. Otherwise, you can go straight to Tom's link for the documents. And again, listed is a link for the certificate as well. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Tom already mentioned this, but I just want to reiterate, if there's anything that we touched on tonight that you have questions about and you need an answer, they're really great with either the phone or the email. They're pretty quick and thorough. So feel free to reach out to them either over the phone or email. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback really guides us as we plan future online events, especially. So not only do we want to know how did this go, but we want to know if there's anything in the future that you'd really like to see. And Tom and Judy are for sure the people you'd want to get that information to. Tom doesn't do a whole lot all day. He just sits around and waits for you guys to say, I really need this. And then he just spends an exorbitant amount of time getting that kind of thing ready. All jokes aside, Tom and Judy both, but Tom, I know, really spent a lot of time getting the documents ready for tonight. So kudos and thanks to both of you for that. So huge thanks to both Tom and Judy. Judy, sorry we didn't get to hear your voice more tonight. But
Hey, I did a heck of a job on the chat.
yeah, you were like Vanna. You were a great Vanna tonight. So thank you.
I'm
And
so
Tom,
sorry.
thanks for taking the wheel and steering us through. And thanks so much, everyone, for joining us tonight. We hope to see you back online next week. Have a great night.